Hello all, the topic of this video is RS flip-flop. But before we go inside the flip-flop, let us quickly relook at these points, at these two different types of circuits. Okay, so first of all we have combinational and the next one is sequential. Combinational, as the name indicates, is the combination of different inputs. Current inputs, and those inputs when combined will give you the output, and hence the name combinational. Whereas sequentials are those which not only depends on the current input but also on our previous results. Okay, so basically that definition is there. Okay, so we'll see that in the combinational circuit, because we are not utilizing previous value, there is no memory unit, whereas in the sequential circuit, because we are utilizing previous outputs, previous result, we are having a memory unit. Okay, so this is what we will be looking at the flip-flops also. Okay, in the flip-flop we'll find this memory unit. They'll be using previous values. Okay, and the examples are given. Then let us quickly see this diagram to make it more clear. Okay, so here is the combinational circuit. You'll see that inputs, outputs, and the combinational circuit. So here you may have many logic gates here. Okay, so it totally depends, the output totally depends on the current combination of inputs. Whereas if you come this side, you'll see that we have the combinational circuit. Okay, so your current inputs are there, but also there is this extra element called memory element. So it depends on the previous values also, stored values, and together they give the output. So that is why it is called sequential. So our flip-flop also falls in that category. Okay, so then now we'll see the definition of what is a flip-flop. So we know that a circuit that changes from 1 to 0 or changes from 0 to 1 when a current is applied. So flip-flop is also that it is a 1-bit storage location. So in one flip-flop you can store 1 bit of data, and it is actually an application of logic gates. When a certain input value is given to them, they will be remembered. Okay, because memory elements are there, so that will be remembered, and with the help of current inputs they will be executed. Okay, and with the help of these flip-flops, electronic circuits, complicated electronic circuits are designed. So that is the use of flip-flop. Now we'll go inside our first flip-flop, which is our SR flip-flop. Okay, so here you'll see this particular diagram here. I hope it is clear. Okay, so here what happens, let me take my pointer. My pen is my pointer here. Okay, so here we have the circuit diagram. Okay, and this flip-flop is designed with the help of NOR gate. There is another implementation also that is using NAND gates. Okay, so let us first see with NOR gate. All right, so here you can see two NOR gates are there, and they and because it is RS flip-flop, what does SR here means? These two inputs. R stands for reset and S stands for set. So these set and reset, I have given the notes, so please go through the notes. Okay, so for the timing you understand that set is setting the value to 0 and reset is setting the value to, or set is setting the value to 1 and reset is making it 0. Okay, so that is two inputs here, R and S, and then we have output Q and another output Q complement. So if a Q prime is the complement of Q. So Q is 1, it means this is 0. This is 0, this means it is 1. Okay, so this is the simple diagram. And then before we go inside the working of that flip-flop, we have to understand the NOR gate truth table. Okay, you all know how NOR gate truth table looks like. So I'm drawing it here. So we have to look at it very properly and try to deduce some pattern. Okay, and then after going through, we can deduce that these two important deductions are there, that if any one input is 1, so wherever you see 1 is there, then output is 0. So these three rows telling you that. And if both output, the first row, if both input is 0, then output is 1. So these two patterns we have to observe carefully. Okay, and it will help us in drawing the truth table of RS flip-flop. Okay, now let us begin. So we draw a truth table like this. Columns are like this, and because we have two inputs S and R, we put it like this. and the output is q, and q prime is the complement. Okay, so if you find q, you can easily complement that, and that will become your q prime. Okay, so let us begin. We are starting with 1 0. Okay, s being 1 and r being 0. So so s is 1. So if s is 1, what is the value of q? Okay, we don't know. We have to deduce that. But from this pattern, we know that if any one input is 1, then output is 0. So that is why this pattern was observed. We will implement it here. Okay, so my one of the input is 1. Okay, so irrespective of the other input, I can say that my q prime is 0. Okay, so if I have one input as 1, q prime will be 0. So I'll put that as 0. And if q prime is 0, very obvious, q will be 1, complement of that 1. Okay, so I'm writing it 1. You can check also if q prime is 0, then so let's say this is 0. So if this is 0, r is 0, 0 0, we know the first row 1. Okay, so that way also you can check, or you can simply write if q prime is 0, very straight away q will be 1. And because it is becoming 1, we call it set. I told you, set and reset. Okay, so this is how we get the first row of the truth table. Now next value is we make it 0 0. Okay, the moment we make it 0 0, okay, we can start with this. So here, what is the value of s? S is now 0. Okay, so s is now 0, and when we have 0, we don't have any patterns like this. Okay, so what do? We have to rely on the next value, next input. So next is q, so we need to know the value of q here. And because last value of q, see, this is memory element, so last value of q we need. Okay, only when we know both the inputs, then only we'll know what is q prime. So we'll take the last value, or let us say q previous, and in the first row, what is our q? 1. So this is q previous, so we take it as 1. So this is 1 and s is 0. Okay, and 0 and 1, 0 and 1 will have 0. Okay, so this is 0. Now this is coming out as 0, so we are writing here 0. Okay, and q prime 0 meaning q will be 1. Okay, so it is coming out like 1 and 0, which, if we observe carefully, is same as previous. Okay, q is 1, q prime is 0 in both the cases. So that is why we write previous when q previous is 1. We have taken q previous is 1. Alright, so that's how we write previous here. And then we go to the third row. So in third row, we make s is 0 and r is 1. Okay, so take the value of s as 0. So s is 0. Alright, so s is 0. So in that case, so s is 0. Okay, so 0, that pattern doesn't help when we have 0. So we'll have 1, because we have 1. So we'll try to utilize that pattern thing. Okay, so we will now focus on r. So r is 1. And we know from the pattern that if any one input is 1, then output is 0. So that is why this time we are going to r. So r is 1, so we put 1. So irrespective of any value here, q will be 0 from this pattern. So when q is 0, we write that as 0, and reverse of that is q complement. Okay, so we have to see where we can use the pattern, and because r was having 1, we utilize that pattern. So we are getting 0 and 1. Okay, then the next value, the fourth row, is 0 0. So again here we have 0 0. All right, so when we have 0 0 here, so again 0 doesn't help much, okay, from the pattern also. So that is why here we have to assume. So let us begin here. We take let us take this part only, s0. Okay, now 0 doesn't give us any idea. So 0, so here that is why, because it's not giving us any idea from 0, we have to take the previous value, just like we did in this case. Okay, so s is 0. So we take the previous value of q. Okay, and previous we get from our row above, and the previous value of q is 0. Okay, so here it is 0, and my q previous is also 0. So 0 0 0 0 gives us 1. 1 is q prime, so we put 1 here. Okay, and the moment it is q prime, we know q will be 0. So if you look carefully, you will find that this is exactly like the previous row. Okay, so this is the second time we encounter a case like previous. So it is same as previous. Okay, so if you compare these two rows, previous written rows, we find that whenever it is 0 0, okay, whenever the value of SR becomes 0 0, the value of Q and Q prime is exactly the previous like the first row. Earlier it was 1 0, so here it's 1 0, here is 0 1, exactly like the previous 0 1. Okay, so whenever we put 0 0, change to 0 0, it will hold the previous value. So I hope these 4 rows are clear. Okay, and then last one is 1 1. We are left with this. So when we have 1 1, okay, then we can use our pattern, this pattern. If any input is 1, then output is 0 in both the cases, okay, in R and S. But then that leads to problem, because we know that whenever we use 1 as any input, then output is 0. So from the top also we are getting 0, that means Q is 0, and below is 1, so that means irrespective of this it will be 0. But Q is also 0, Q prime is also 0. How is that possible? That is not possible. That is why this kind of behavior leads to what is known as invalid state. Okay, so that explains our truth table. Very, very important. Okay, please watch this video very carefully. This truth table generation is a very important process. Okay, and important to know this pattern, and from the pattern how we can implement. That's why if we have 1, okay, we have to see where is 1, and on that in that 1 value we can apply this. And whenever there is no 1, then we have to make use of the previous state. Okay, so in the previous state we have to find. So in these two cases we utilize Q previous and assume get the new value of Q and Q prime. Thank you.